New images from Hawaii's Gemini Observatory North have just rewritten everything we thought we knew about 3I Atlas. At first, it looked like a single interstellar traveler, a lone visitor passing quietly through our solar system. But the latest data suggests something impossible. Atlas might not be alone, because surrounding it are multiple luminous companions, moving in perfect unison. If this data is real, we're not observing a comet. We're witnessing coordination. In astronomy, formation flight doesn't happen. Natural objects don't maintain cohesion over millions of kilometers. They drift, collide, or disperse. And yet that's precisely what Gemini's latest observations suggest. When the images were processed, researchers noticed several discrete points of light traveling alongside the main body of 3I Atlas. Not visual noise, not background stars, each one tracked across the sky in precise synchrony, holding position like satellites locked in invisible orbit. Teams immediately ran through the checklist of ordinary explanations: lens flare, cosmic rays, optical distortion, all ruled out. The data was verified independently by amateur astronomers from Chile, Germany, and Japan. Each confirmed the same eerie truth: multiple objects, same vector, same speed. If this were fragmentation of pieces breaking off under solar stress, we'd expect chaos, debris clouds, irregular spin, fading trails. Instead, what we're seeing is something far more disciplined: coherence, stability, intent. And that's what troubles scientists most, because nature creates beauty through randomness, not geometry. Yet these companions appear bound by invisible order, almost as if they're following a shared instruction. Fragments scatter, these stay in formation. When a comet fractures, it doesn't glide gracefully, it erupts into chaos. Gravity and sunlight tear fragments apart, sending debris tumbling unpredictably through space. That's the physics we know, the universe's default setting. But 3I Atlas refuses to play by those rules. Across multiple observatories from Hawaii to the Canary Islands, even backyard telescopes across Europe, the same phenomenon appeared. Tiny luminous companions keeping pace with Atlas in unbroken formation. Their motion was clean, constant, mathematically precise. No deviation, no drift, no sign of instability. Then came the anomaly that no one expected: the green flash. Captured by several amateur astronomers, it wasn't a photographic glitch or camera flare. It was a real burst of light, a subtle emerald pulse blooming from the region surrounding Atlas, then fading into the dark. Comets often glow green due to diatomic carbon, simple molecules fluorescing under ultraviolet sunlight. But spectroscopy from Chile's Very Large Telescope revealed something astonishing. 3I/Atlas is almost completely depleted of carbon chains. There shouldn't be enough molecular material to produce that glow at all. In other words, the light is real, but the cause isn't. Something else is creating that eerie hue. Maybe plasma interacting with solar particles. It may be a reaction we've never cataloged. Or maybe something designed. Whatever the source, the laws of cometary chemistry don't explain it. And that's what makes scientists uneasy. Because in the language of astrophysics, light always tells a story. And this one, whatever it's made of, shouldn't exist. A comet missing the chemistry that makes comets glow. What truly sets 3I/ATLAS apart isn't just how it moves, it's how it survives. A few weeks ago, a coronal mass ejection, a surge of charged plasma erupting from the sun, blasted directly across its path. Any ordinary comet, especially one moving at over 100,000 miles per hour, would have shattered instantly. But 3I Atlas didn't just endure the storm, it passed through untouched. No loss of brightness, no visible fragmentation, and no thermal disruption of any kind. That level of resilience shouldn't be possible for something made of dust and frozen gas. It suggests an internal architecture unlike anything nature casually assembles. When scientists analyzed its light curve, they found something remarkable. The object's density is far lower than it should be for its apparent mass. It behaves as if it's hollow, a shell enclosing empty space. Now, hollowness in space isn't just rare. It's impossible for a naturally formed comet. Gravitational collapse compacts material inward, not outward. But if an object were built, not born, hollowing it out would make perfect engineering sense. Less mass means less inertia, easier maneuverability, stable rotation, and stronger structural integrity under stress. A hollow shell can also regulate heat internally, absorbing radiation on one side, redistributing it evenly across its surface. That could explain the temperature consistency observed even at low temperatures. After its solar encounter, of course, no scientist is ready to declare 3I/ATLAS an artificial object, The moment we use that word, proof replaces curiosity and the investigation ends. But numbers don't lie. The math reveals balance, symmetry, and efficiency, patterns that look less like geology and more like geometry. So we tread carefully because, as one physicist quietly remarked, this isn't proof of design, but engineering sense hides in the math. Just when scientists thought they'd mapped the limits of 3I Atlas's strangeness, NASA's Swift Observatory added a new puzzle, one that defies every model of cometary behavior. At a distance of nearly 3 astronomical units from the Sun, where most comets remain inert, locked in deep freeze, Swift detected something extraordinary. 3I Atlas is venting water vapor, not sporadically and not faintly, but at a steady, relentless rate of nearly 88 pounds per second. To put that in perspective, that's like a small swimming pool of water turning to vapor every hour from an object still far beyond the solar region, where heat can trigger such activity. At that range, solar energy is simply too weak. Nothing natural should be boiling off that much water that far from the Sun. So where is the energy coming from? Some researchers propose that 3I Atlas possesses an unusually porous structure, allowing solar radiation to penetrate deep within and heat trapped ices from the inside out. But that explanation doesn't fit the data. The venting is stable and rhythmic, not random or chaotic, almost as if some internal system is regulating the process. If the hollow structure theory is correct, then that same cavity could act as a kind of thermal chamber, redistributing absorbed energy evenly and releasing it in precise cycles. That's not chaotic thermodynamics, that's management. It's the difference between fire spreading across a forest and a controlled burn. And here's where the data gets eerie. The emission rate has barely changed in weeks. No fluctuation, no decay, just consistent output as though following an internal clock. Maybe it's natural, maybe it's not. But one fact stands above all the speculation. Something inside 3I/Atlas is alive with process, not chance. When the Gemini data first showed multiple points of light following 3I/Atlas, the natural reaction was to assume fragmentation. The main nucleus shedding debris as it neared the Sun. But weeks later, those fragments haven't dispersed. They haven't drifted apart. Instead, they've remained locked in near-perfect synchrony, tracing the same orbital path with eerie precision. To a physicist, that kind of behavior isn't random. It's governed. Each companion mirrors the motion of the primary body, adjusting speed and distance as if connected by invisible threads. That pattern defies the chaos of natural disintegration. There are no widening gaps, no collision cascades, no dust plumes, just a quiet, coordinated dance through space. Some astronomers have begun referring to it as gravitational choreography, an elegant phrase for something we can't yet explain, because gravity alone can't account for it. Even at interplanetary distances, tiny variances in mass or momentum should cause these companions to drift. Yet they don't. They stay close, steady, deliberate, disciplined. And here's the unsettling part. Every time Atlas changes brightness or rotation rate, the smaller companions respond within minutes. Their light curves pulse together like synchronized beacons. That suggests feedback, some shared mechanism linking their behavior. If they're fragments, they're the most disciplined fragments in cosmic history. If they're independent bodies, they're moving with coordination nature rarely, if ever, achieves on its own. So scientists now face a question that feels more philosophical than astronomical. Are we watching the debris of a breakup or the precision of a design? Is this a coincidence sculpted by celestial mechanics or evidence of something far more intentional? Every image, every light trace, every pattern seems to whisper the same impossible thought. What if we aren't watching a comet pass by, but a fleet passing through? Every discovery has a rhythm, observation, analysis, publication, debate. But every time something arrives from beyond our solar system, that rhythm breaks. When Umama appeared in 2017, early radar and spectroscopic data were quietly delayed for months. Researchers claimed calibration issues, but portions of the data set never resurfaced. 2 years later, Borisov entered our system. Another interstellar traveler, another gap. Some chemical readings were released publicly, others quietly redacted. And now in 2025, as 3I Atlas passes through, the pattern repeats. Data exists, we know that. Multiple agencies have confirmed successful observations, and yet the public record remains empty. No images from Mars orbiters, no confirmed spectra from Webb, no official briefings. Three events, three silences, each arriving precisely when the evidence challenged our models the most. It's no longer coincidence. It's choreography of a different kind. The same institutions that celebrate every exoplanet, every dust storm, every black hole image go quiet when the universe breaks their rule book. Maybe it's caution, maybe it's fear, or maybe it's something subtler, a decision made behind closed doors to pause before redefining reality. Three visitors, three silences, and now perhaps one reason. For all our technology, telescopes, and data models, the most unpredictable force in any discovery isn't the cosmos, it's us. When the unknown stares back, humanity hesitates. Not because we lack the tools, but because we fear what the answers might mean. Every generation of scientists has faced this moment when evidence grows louder than belief and belief resists surrender. Perhaps this global silence surrounding 3I Atlas isn't a conspiracy at all. Maybe it's something far more human. Fear of misinterpretation. Fear of triggering speculation before verification. Fear that releasing one unconfirmed image could ignite a storm of sensationalism, drowning real science in noise. Because science at its core doesn't fear the unknown, it fears premature certainty. The greatest danger to discovery isn't ignorance, it's the illusion of understanding. So maybe this hesitation isn't cowardice, maybe it's restraint. An instinctive pause before rewriting the very definition of natural. And in that pause, in this eerie global quiet, we might be witnessing something profound, humanity learning for once to listen before it declares. Whether 3I/ATLAS turns out to be a fragment of cosmic debris or something deliberately sent, it's already forced us to confront the limits of our comfort zones. It's reminded us that humility is not weakness and that the unknown isn't an enemy, it's an invitation. Because in the end, science and wonder are born from the same impulse to reach toward what terrifies us. And look anyway. Whether fragment or message, comet or construct, Atlas reminds us, curiosity is the opposite of fear. Perhaps 3I Atlas isn't a comet at all, but a question written in motion, a riddle etched in ice and light, drifting silently through the void, asking whether we're ready to understand what we're seeing. For centuries, we've been the observers, building instruments, mapping skies, chasing signals. But maybe for the first time, the universe is observing back. Maybe this object isn't crossing our system by coincidence, but by design. And so we wait, between fear and fascination, watching a traveler that refuses to explain itself. Because sometimes the silence between stars says more than any transmission ever could. If this was NASA's worst nightmare, a discovery they couldn't categorize, wait until you see what comes next. The next chapter begins where the data stops and the whisper turns into something far louder.